Hello everyone, welcome to On Tuition. So in last few videos, we are trying to solve few numerical questions based on the properties of conductors. So what does this question say? It says that a charge plus q is placed at the center of a cavity of radius a made inside a spherical conductor of radius b. Find the electric field at point P at a distance x which lies between a and b from the center due to the induced charges on the inner surface of the shell and the potential and of the conductor as well as the potential at point P. Okay, so now what is the difference of this question and previous questions that we have discussed is that the cavity made in this question inside the conductor is not concentric. The cavity is off center. So इस question को हम लोग कैसे solve करेंगे? So first let us draw the charge distribution of the cavity as well as the conductor. Okay, so as you can see that we have placed a positive charge at the center of this. So this positive charge will induce a minus q charge at the surface of cavity, and this plus q charge will be induced on the surface of the conductor. And you should know that the outside charge distribution is independent of the inside charge distribution. So outside charge distribution will be a uniform charge distribution. So if I have to find the electric field at point P, then we will use the property of the conductor that says that the electric field and potential outside the cavity is 0 for all the charges that are inside the cavity including the induced charges. तो P पॉइंट में जो इलेक्ट्रिक फील्ड आता है वो अब टोटल जो इलेक्ट्रिक फील्ड है P पॉइंट में वो प्लस Q चार्ज के चलते भी है और ये माइनस Q इंड्यूस चार्जेस के चलते भी है एंड टोटल इलेक्ट्रिक फील्ड हो गया 0. तो इस P पॉइंट में अगर मैं इलेक्ट्रिक फील्ड निकालना जाऊँ तो we can say that at P point the electric field due to plus Q and the electric field at P point due to minus Q induced is equal to 0. So what will be the electric field due to minus Q that is induced, that is equal to minus of electric field due to the plus Q charge, and that is simply minus of kq by x square x cap. So this should be the answer of this question number 1. And the second question says the potential at P. Similarly, potential at P is not contributed by any charge inside the cavity. Total potential at P due to all the charges inside the cavity including this minus induced charge is 0. So this point potential is only due to the outer surface charge distribution. So if I only take the outer surface charge distribution, it is a uniformly charged spherical shell, and inside at any point the potential is simply kq divided by the radius of the shell, that is P. So that is the potential at point P, and also this is the potential of the conductor, because potential of conductor is the potential of any point inside the conductor, and P is itself a point inside the conductor. So potential of P and potential of the conductor are same. Now in the same question, if I ask you to find potential of point P where the distance x is less than a, that means if I take this point P here and this is x, then what will be the potential at point P? Now we can do it by superposition principle, that for plus Q charge the potential at this point P, which is at a distance x from plus Q, is simply kq by x, and for this uniformly distributed spherical shell, potential at any point inside is minus of kq by a, and for this uniformly distributed spherical shell which represents the outer surface of the conductor, at any point inside the potential is simply plus kq by b. So the net potential inside any point of the cavity which is at a distance x from the center is kq into 1 by x minus 1 by a plus 1 by b. So that should be the answer.